name is Daniel DiCapua. I am a physician at Yale University, and today we will be discussing pupillary control and a Horner syndrome. Control of the pupil is mediated by the autonomic nervous system. Miosis, or pupillary constriction, is mediated by the parasympathetic nervous system. Mydriasis, or pupillary dilation, is mediated by the sympathetic nervous system. During the light reflex, light enters the pupil and stimulates the ganglion cells of the retina. This afferent stimulus is converted to a nerve impulse and transmitted to the central nervous system via the optic nerve before synapsing in the pretectal nucleus of the midbrain. From the pretectal nucleus, neurons project to the Edinger-Westphal nucleus. The Edinger-Westphal nucleus sends its axons via bilateral oculomotor nerves, or cranial nerve 3, to synapse in the bilateral ciliary ganglion. The iris sphincter muscles are ultimately innervated by the parasympathetic neurons from the bilateral ciliary ganglions. Sympathetic control of the pupil starts in the hypothalamus with the first-order neurons for mydriasis. These synapse in the ciliospinal center in the cervical spinal cord. The second-order neuron exits the spinal cord and ascends via the sympathetic trunk to the superior cervical ganglion. The third-order neurons ascend via the neural plexus along the internal carotid and ophthalmic arteries. These ultimately innervate the pupillary dilator muscles via the long ciliary nerves. In a Horner syndrome, the sympathetic nervous system is affected. Horner syndrome is a constellation of clinical findings including ptosis, miosis, and anhidrosis. Damage to the sympathetic innervation of the eye and face will cause loss of pupillary dilatal muscle innervation, ptosis or loss of the superior tarsal muscle innervation, and anhidrosis or inability to sweat. This often appears as flushing of the face with decreased sweating.